Hello everyone, my name is Prajwal and today we are going to discuss this problem 3 friends. This is rated as cakewalk and it might require you a little bit of maths like linear equations to solve this problem. So guys, if you have not read this problem, go back, read it, try it out and then come back and watch the solution. So in the problem we are given 3 friends A, B and C. Now A says I have X rupees more than B. B says I have Y rupees more than C. C says I have Z rupees more than A. Now we are also given that having minus R rupees more is actually same as having R rupees less. This means that these x, y, z can be negative as well. So in the question we are given the values of mod x, mod y and mod z, and we need to calculate whether there exists any combination of x, y and z which makes all these statements as true. We need to output yes and no accordingly. The constraints given to us are, we are given about 1000 test cases and the values of mod x, mod y and mod z can range from 1 to 1000. So guys, let us go over to the first test case. In the first test case, we are given as x as plus minus 1, y as plus minus 2 and z as plus minus 1. So now we need to choose x, y, z such that these equations are satisfied. So let us say that we choose x as 1, y as minus 2 and z as 1. So if we try to solve these equations, we will get one of the solution can be 10, 9 and 11. Another solution can be 2, 1 and 3. So we can find RA, RB, RC satisfied by these values of x, y, z. Hence we print yes. In the second test case, you will find that there does not exist any combination of x, y, z that will make all these claims true. Hence we output no. Moving on to the solution. For problems like these, we generally try to solve these equations and try to come up with some condition that will help us figure out whether the answer exists or not. So let's solve this equation. Let's get the values of C and B from first and third equation and put them in the second one. So from this equation we can see that B is equal to A minus X. From this equation we see that C is equal to A plus Z. Let's put this equation in equation number 2. So we get A minus X minus A minus Z is equal to Y. From this we can derive that X plus Y plus Z equals 0. So now we are left with this condition X plus Y plus Z equals 0 and we are given the value of mod X, mod Y and mod Z. So the number of combinations are 2 to the power 3 which is 8. We can try all the possible combinations of x, y, z, x, y minus z up till minus x, minus y and minus z. We can try all these 8 combinations and if any of them satisfies this condition of x plus y plus z equals 0, then we know that our answer exists and we output yes, else we will output no. So guys, let us look at another solution. Let us transfer z on the other side. Now this tells us that z has opposite sign that of x and y. Why this is true is because if x, y and z have same sign, then x plus y plus z can never be equal to 0. So we can guarantee that z has opposite sign that of x and y. So we can go ahead and apply mod both sides. Since x and y have same sign, we can further simplify this to get x mod x plus mod y equals mod z. So now we are given the values of mod x, mod y and mod z in the problem. We can also go ahead and say that this z has to be the largest value among the three values. This is true because we can assume without loss of generality that x and y, x is less than y less than z. So if x plus z has to be equal to y, so this condition can never be possible because z is greater than y. So x plus z will always be greater than, much greater than y. Hence this condition is always false. So now we can sort x, y and z and check that if this sum of two smaller number is equal to the larger number, then we output yes, else we output no. So guys, in the first method, we were actually trying to iterate over all the possible combinations, which were just 2 to the power 3, which is 8. Hence, the time taken is order of 1 per test case. And the space complexity is also order of 1 because we require only some variables to store all the data. In the second method, we simplified our conditions to checking whether the sum of smaller 2 is equal to the large or not. This is also order of 1 in time, and space is also order of 1. So guys, let us go over the code quickly. We will use a temporary variable possible to tell us whether the answer exists or not. We can simply iterate over all the possible combinations. Now I have used temporary variables to tell us whether the sign should be positive or negative. So if I and 1 is greater than 1, that means the first bit is 1. We basically use x, else we'll use minus x. We'll do this similarly for y and z. For y, we have to use 2 because we have to check the second bit. Similarly, we'll do this for z. For z, we use 8 because we check the third bit. Now we use the condition that if x plus y plus z is equal to 0, then we make possible as 1 and we break out. So finally, if possible is 1, we output yes, else we output no. So guys, this is pretty much the whole code, and if you try to code it yourself and if you face any issue, then come back and watch it again. So guys, I hope you understood the problem well, and if you have any questions, drop a comment below and like the video, and don't forget to subscribe to get the latest updates from CodeChef. Thank you and goodbye.